Just before I start, I've been asked to make a few announcements. DVD sales of all talks are taking place at the vendor area just outside the front there, as are Robert Steele's books. There's unscheduled track information in the Zeus room, hacking at NGOs at 9 o'clock, and at 11 o'clock, discussion session on hacking the body. Right, if anybody can't understand my accent or I'm speaking too fast, just shout. I'm from a land near England called Scotland. And this is one of our oil refineries picture here, so it's topical. Right, the usual disclaimer. I have no qualifications in the subject area. Don't believe anything I say without doing independent research. And as usual, there's lots of differing opinions depending on your political persuasion, etc., etc. Right, so as I've already told you, I'm from Scotland, so how did I get to New York? And obviously my talk's about the environment, so that's going to be a bit tricky. So first of all, boat, quite naturally. So I looked to see when the next ferry was along. Hadn't been one since, I think, 60s or 70s, so that was kind of out of the picture. So the only two other options I could find was cruise ships or freighters. So I looked up the cruise ship sailings. So the Queen Mary leaves Southampton on July the 16th. July the 16th, and it takes 6 days. So I'd have missed the conference. But I could. The previous one was on June 2nd, so I'd have had a good stay in New York. Probably run out of money, but I would have still had a good stay. And there's a nice convenient one sailing back, leaving the July the 22nd. The fares are a bit pricey, and that was the fares start from, but I don't think I could have got any of them. Freighters, unfortunately, don't take the direct route. They take about 13 days each way, and they go to slightly strange places if you're a passenger. They do come to New York, but via Spain and things. And they're a little bit about the same price as a cruise ship. So airplanes, or aeroplanes as I would pronounce it. Direct flight, 2 flights per day, just under $1,000 for the return trip. So which do you think I chose? Well, before I tell you that, I'll go on to the nitty-gritty of the numbers. So we're all led to believe that planes are these terrible carbon-emitting vehicles, and to a certain extent they are, but based on one metric I'm going to use here, which is energy consumption. An ocean liner, so I think that's something along the lines of a QE2, so a passenger capacity of about 3,000. It uses about 100 kilowatt hours for every 100 passenger kilometers, whereas a 80% full Boeing 747 has a better energy consumption, although it depends how full it is, obviously. So looking at these figures, flying is more sustainable than boats. So or what we've been led to believe, is it wrong? Well, this is on our ocean liner. If you went back to the ferries, so in sort of Titanic type boats, well, although that's a bad example, where you had your sort of first class, so lots of room. I don't think they had a swimming pool, but that sort of entertainment, the band and things. And then you had your sort of hostel, lots of bunk beds, third class. So if your boat was packed to the rafters, I'm sure you could get much better numbers than a plane. And of course, there's more complications, like greenhouse gases have a greater effect at a higher altitude and blah, blah, blah. So I booked the flight. So I'm sure most of you have come across this thing. I don't know when it sort of first started. If anybody knows, speak up. But carbon offsetting is this wonderful thing where you go to the website, and in fact some flights actually provide it as part of the booking process, and it gives you this monetary figure on how you can do something to offset the carbon that will be released by your flight. And that will be used in various projects, plant trees, buy energy saving lighting, build a hydrodam. One of the things that I noticed about these is they are mainly projects based in the developing world. So it's an idea of you take your plane flight and we'll get somebody else to reduce their carbon footprint to make up for your extravagance. So it doesn't really encourage you to cut back. But you get a nice warm fuzzy feeling, and so you get this nice little web form that says for the return flight it's £12. And in fact, I think I also got an option to, as part of my flight, that was $10, which I thought was ultra low. So what sort of underpins environmental threats? So there's lots of different environmental threats, some more significant than others. But what I'm putting forward here is sort of if you trace things back to the source, probably economics would be a reasonable guess. The
largest single user of petroleum in the world is the U.S. military.
Yeah, that was one of the things I came across in research. Was I'll give you some references. There's a professor from Cambridge University in England who's sort of drafting a book with a whole load of its energy related figures, and he worked some figures out for the UK military for their sort of overall energy usage in Iraq, and that was quite considerable. So some planet saving theory. Some of this is probably familiar to most people. So there's, like all these things, there's 3 R's. So it's reduce, reuse, and recycle. So I'll just sort of go through some of these in a sort of hacker, technical type of scenario. So I don't know if you've had it in the US, but in the UK, there's sort of mass media, so things like the BBC have run a news story, and at the end or something they say, remember, unplugging your mobile phone charger can do blah. So, wrong button. So people have done some experiments, and plugging in a phone charger with the wall wart while your phone's not plugged in or being charged wastes just under half a watt in heat. So, well, a watt is like an instantaneous measure of power consumption. So I'll come on to what kilowatt hours is actually consumed. because
How much would be used in one day, let's say, from that single application?
Well, it'd be easier to compare it to a light bulb. So like a standard 100-watt light bulb, this would be 1/200
I-
of the power of a standard light bulb.
I think we've got some telepathy going. So apparently there's 70 million mobile phones in the UK. I think there's actually less people in that. So I think some may be sitting in cupboards or sitting in a landfill site with a contract, so they're still connected to the network. So I'm being quite conservative in saying if 30%, so that's of the total, so I think this is maybe overstating it, were to leave the chargers on constantly, so this half watt drain, then over the course of a year, which I haven't put in my slide, but it's over the course of a year, about 90 gigawatt hours would be consumed. So what if the same thing? What if each household? So apparently there's about 24.7 million households replaced a standard 60 watt with a equivalent uses 11 watts of energy. And assuming that light was on for 3 hours a day, over the course of the year, that would be about 1,325 gigawatt hours. So you can see that it's quite low. But that's to be, you shouldn't leave your mobile phone charger plugged in, but I think sometimes they're used as a scapegoat. There's similar things for standby on certain appliances, although historically the standby mode has been particularly wasteful. Another little comparison. I'm sure lots of us know about these CCTV cameras. UK, I think, is probably one of the most densely populated areas for CCTV. It's everywhere. Double-decker buses have about 8 CCTV cameras spread about the bus, and in fact have a small LCD display at the front of the bus showing you all the camera footage on a cycling thing. So I haven't worked out the power consumption one of them, but it must be considerable. So if they were to run 95% of the time continuously, which most of these cameras are, and I've plucked the figure 5 watts out there, a lot of these cameras use less than that, but all the recording equipment and so on will probably use that. So that's using about 170 gigawatt hours. So that's a bit more than the mobile phone charger, but it's still quite a lot. So PC power consumption. Just have a show of hands. How many people leave at least one PC on 24/7, 365 days a year? I'll have to put up my hand too. Although I'm thinking of ways of not doing it. I used to have 2 or 3, but now it's down to 1. So another raise of hands, when you had your first computer, whenever that was, did you run that 24/7? So that's interesting.
Windows crashed if I left it on for longer.
So we should make software that crashes more often. Right, so I'm sure quite a lot of us can't be away from their computer for more than, hours, days, months. Anyway, and you want to be able to remote connect, however, insert protocol here, to your home PC, your work PC, so you have your operating environment as you left it. So that, most of us know about the suspend to disk hibernate, which incidentally this laptop didn't come out of hibernate mode, so maybe what I'm going to say is not quite true. So that over sort of last 10 years, that's been more or less a standard thing. So if you combine that with Wake Up on LAN, so this is a technology that's been around for quite a while, been put onto motherboards, whereby if you send a magic packet to the machine that is powered off although it's obviously going to have to be using a bit of power to keep its network card up and listening for packets. Then the machine will start up, and if it's been hibernated, it will return to its previous state. Oh, need to look at the arrow keys. But a bit of a clue in the name, wake up on LAN, so local area network. So if you're out in the wilds and you want to wake up your home PC, how do you do that? Well, I haven't got this working because my router doesn't support this particular hack, but it's possible to set up port forwarding for the particular protocol that it uses to send it to the broadcast address in your internal network. There's some articles online if you sort of Google for that, on how to do that. And this one of these threads that's been going for years, and I'm sure will continue for years, is switching on and off for PC. Does it reduce its hardware life? So does it, it's more likely to the hard disk to fail, or is the motherboard going to break in two because of thermal shock? So I would say things like disks and fans, if they're not running, they're not subject to wear and tear, but it's still a topic for discussion, I guess. So canned air, this was something I just came across. I've never used it, but I was actually looking to use it. So another show of hands, how many people have used canned air to get that dust out of things? Right, so reasonable number. Hands up if you think it's got air in it. Good. So there's not a lot of air. There's probably a bit of air, but it'd be trace amounts. So they use an HFC. Now I'm going to try to pronounce this. If there's any chemists here, don't laugh. Tetrafluoroethene. Now, I think there's a few different HFCs being used over time. So it's like a refrigerant, so it's used in other applications as well. So I guess if for the people who have used canned air, I bet you've turned it upside down and frozen things and.
34A is what they use in cars after 96.
Yeah, coming on to that. So there's I forget the name of it. I haven't put it in here. It's some scientific term about the I was going to say effectiveness, but that's probably the wrong word. The effectiveness of substances for global warming. So HFC 134A has about just over 1,300 times the effect of the same volume of carbon dioxide as a greenhouse gas. People are taking notice. The EU has banned it from new automobile air conditioning after January 2011. So it's cutting edge. Fix the problem now. And I'm sure lots of other applications like canned air will be changing to another similar compound which has less greenhouse gas potential. So alternatives exist. There's something I came across which looked like a can of canned air, but in fact you could pump it up with a bicycle pump. So you pumped on it for a couple of minutes and that would last a wee while. I guess it wouldn't take that, wouldn't last that long because air doesn't compress particularly well. And obviously if you eliminate the need for the aerosol can, the transportation, etc. And I forget what the name of this, but it's like a squeezy thing, but it kind of looks like a bit like a spaceship. Reminds me a bit of the CCC rocket. Right, so there's all these sort of problems and things like that. And all these talks of renewable energy. But what is something that's quite simple that we can maybe do that doesn't involve lots of energy? So producing photovoltaic solar panels. So solar panels that take sunlight and turn it into electricity. They take quite a lot of manufacturing and the waste processing things. So I'm going to give the example of solar hot water, which is quite sort of hacker friendly, as you'll see in a minute about how to do it. So you can go down the professionally installed system. So lots of companies have sprung up with this sort of green drive to sell you their wares. So it's equivalent of about $6,000 to $10,000 for domestic property, which is quite a lot of money, even if fuel prices increase. And around the world, there's different government grants, some better than others. So sometimes you can get some slightly better deals. Although quite often you have to jump through a lot of hoops and have more complex systems to get the grant. But there's the sort of middle ground, which is do-it-yourself kits. So they're slightly cheaper, so you get the kit from your local DIY store, you take it home, you install it, they've got instructions. So going back to the economics thread, the payback for these can be forever, almost. If you spend $10,000 on a system and you only save $1 a day in hot water heating, you can work it out. Obviously it depends how much sun. Well, sun's the wrong thing. Daylight is perfectly fine to heat hot water. So even in cooler climates such as the UK, you can get quite good amounts of daylight. And in hotter, sunnier climates, it's even better. So as fossil fuel energy costs increase, then the payback period is reduced. But there's a hacker way of doing it. So go dumpster diving, find some materials, so wood, bits of aluminium, piping, etc. Usual things apply. People say, oh, you can't do that. You've got to go and buy the shiny sticker. Prove them wrong. It won't work first time, certainly. So keep working at it. With solar hot water, the technology is quite simple. You take your water, you pass it through the panel, you get hotter water. But you can go down much more complicated routes. So some solutions involve pumps. You can do your comparisons of temperature in and out and decide whether your solar panel is actually reducing the temperature of your hot water. Question?
Actually, there's a couple of designs out there already.
Yeah.
There's one called Siege, SIETCH, with one design used an old refrigerator spiral.
Yeah, I'm coming to a few other things. Yeah, there's hundreds and hundreds of things out there. Yeah, your search engine is your friend. So the payback period is going to be much reduced. So if you scoundrel materials for free, and since our time is free, then you can pay it back almost instantly. And with a bit of luck, you have some fun. So just a bit of boring stuff about planning permission, permits and things. So you don't have people coming around and saying, tear it off your roof. Obviously there's practical solutions. So if you live in an apartment, flat, it's kind of difficult to stick it on the roof. You'll have to either get the landlord or all other neighbours involved. Although I came across one sort of thing when I was doing my research, searching the web, that there was a balcony-based solution or I saw another one which was literally sticking it outside their ground floor window. So it can be done if you're not wanting to involve lots of putting things on roofs. And yeah, there's a sort of picture of one of these sort of homemade ones. So I think this is it looks of it, a bit of aluminium on the back and probably some copper tubing that's been painted some sort of grey colour. So a dark colour obviously works better because it will absorb the heat. One of the solutions I came across that people have been doing online was actually to use silicon piping. In sort of the colder climates such as Scotland, in the winter one of the problems is that if there's water left in the panel, it will freeze, and if you use copper piping, you'll get cracked pipes. So if you use something that will expand a little, that helps a lot. There's also sort of two different methods to be used. So there's direct or indirect heating. So the indirect method works by heating some water and then running it through a coil inside a hot water cylinder. So the water that's actually passing through the panel is not what you use from your hot tap. A lot of the professional systems generally use that sort of approach, and the way they get around the freezing problem is to actually put antifreeze in that water. So it has to be changed every few years, and there's obviously environmental impacts for the antifreeze. And the direct system literally takes the water from your hot water cylinder, puts it through your solar panel and sends it back into the hot water tank, where hopefully it's got a little bit hotter. So sort of going still on the topic of reduce. So this is got the photograph from Flickr. I think this is a Spanish TV store or something. So I think they're selling things downstairs, or you can make your own things. TV begons, anybody heard of them? Plus, if you notice in the ceiling, they've got these, I think they look like halogen downlighters. So these things that, I think retail stores have a lot of them, where they, I think they consume about 60 watts, something like that. So see how many you can see there, quite a lot. And the light output's a bit rubbish, I think, as well. So they should have long fluorescent strip lights in the store. So going now on to sort of, I guess, more reuse and recycle. So this was a picture, I believe, taken in London somewhere, of somebody's monitor that had been dumped in a stream or river, seeping lead out. So yes, reducing computer waste. So using less hardware. So I'm sure lots of us will be sick to death of the V word. And I attended a talk earlier talking about the security aspects of virtualization and how that virtualization is not particularly segregated. What the vendors say may not, in fact, be the case. So does computer equipment need replaced as frequently as it is currently? So a lot of these corporations and large organizations have a policy to replace their hardware somewhere between three years, and I think the sort of longest would probably be 6 years. And after that period, the hardware is perfectly usable. The failure rates might start to increase. Again, they might be running at 24/7 needlessly, which could reduce the lifetime. I'm going to have to get a new finger. Another thing is, jumps the whole thing. Should software have more modest hardware requirements? So I'm not going to name a particular product. Begins with a V, I think.
Yeah.
Question?
So do you have any thoughts about if you want to replace your
Yeah, well, because there's obviously this energy taken to produce the new computer, transport it generally to and from China at least twice. The components are made somewhere, transported, etc. And obviously, the trade-off is if your computer's using 4 times the amount of electricity, then maybe that's worth it. You've also got to consider the energy and the impact of disposal, which is where reuse is something, if you can do, that's better. So can you reuse your equipment elsewhere? So just because it can't be used for your high-end graphics design, it doesn't mean it can't be used somewhere else. So in a level of cascading, so you can probably take 2 or 3 levels until it becomes absolutely and utterly obsolete. So the public terminal area downstairs, if you've come across that, there's some machines there which have been down a few levels, I think, of this waterfall. So charities, non-profits, if it's able to donate it to them, I'm sure they'll find a use for it. Again, I'm sure some of us are involved in working with them to help them out with their computers. Again, social projects, community projects that give people access to technology. Friends, relatives, although you've got to watch they don't come back to you for computer support for the rest of your life. And local free cycle, so just have a mailing list where you can offer up goods locally and people will come and collect them. And if you can't reuse it, it's recycling, which quite often actually just is responsible disposal. So there's all sorts of legislation. I don't know about there's probably some American equivalent, but there's an EU, I can't remember what it stands for, waste, energy reduction, something or other. So that's putting responsibility onto equipment manufacturers to take equipment back at the end of its useful life. And I think they're supposed to try to reuse it, but very often it's melted down in the component metals reused or disposed of.
Is that related to the thing that in the EU you can't make it out of certain materials that are known to be hazardous or whatever?
Yeah, the question is, in the EU, can you make your equipment out of sort of toxic materials? There's a related statute called ROHS, which is Reduction of Hazardous Substances. So they sort of go hand in hand. So the idea is that when you do need to do your recycling or disposal, that it's easier to do. So quite often it's trying to reduce the number of component hazards, so it's easier to extract. So with all this talk of increased fuel costs and increasing temperatures, are we going to reach a crisis point? I'm not going to answer that. I'm sure nobody knows. So the impression is that current levels of resource consumption are increasing, especially with the likes of China and India increasing a lot of their industrial production, although in some cases it's moving it from other parts of the world, Europe, US, into those countries, so it's maybe not a total increase. One of the things that I came across was in the news the last few weeks was that as part of the drive to reduce oil prices, OPEC, the sort of oil producing cartel, I don't think they'd like me calling that, but that's probably what a little bit like it is being encouraged to increase production because one of the rules of economics is increase the supply, the price is likely to go down. So that might work in the short term, but if oil being a finite resource, you're just moving your date where your oil supplies run out sooner, so that when you do reach that point where the supply is diminished, then you're going to have a bigger effect of oil prices. One of the things about oil production is there's different oil fields with easier extraction costs, so both in monetary costs and environmental costs. So a lot of the easy oil is probably diminishing, so there's going to be much more difficult and time-consuming drilling activities. So I guess there's not going to be an overnight change. There's not going to be a crisis tomorrow, but it will be over probably a period of a few decades, so it might be in some of our lifetimes, children, grandchildren. Obviously there's predictions, and I didn't want to go into too much detail of the predictions because there's so many conflicting ones. They go from between about 50 years and 150 years for oil. So a lot of the solutions bound about is we can just make our technology much more efficient, so we can increase the power efficiency of all our PCs. We can make more efficient cars. Is that going to help? Well, there's probably a psychological effect with, oh, my car doesn't pollute as much or it uses less gas. Well, I can drive a bit further then, so you're back in the same position. One of the examples I got of that is using waste cooking oil to run cars. So you can run diesel cars off waste cooking oil after doing a bit of filtering, etc. So there was a media article I saw where at the end the driver who'd done this process said, "I don't feel guilty as now using my car, and now I know it's using waste oil." So what can hackers do if we get to this sort of crisis point? So once we've reached that point, once the oil's run out, the resources there'll be very few resources left to use. So we're going to have to make do with what's left. So all the plastic cups, the plastic trinkets, the empty cans of canned air, they're what we're going to have to be left to make do with. So we'll be probably digging up landfill sites. So possibly conventional engineering and science may be slow to react. Quite often developments may be a couple of decades to come to fruition. So using things in unusual and creative ways is probably something that comes pretty naturally to us. So that might be where we'll be able to help out. So, for example, my watch strap is actually a garden tree tie. So you buy a cheap watch. The watch battery probably lasts about 5 or 6 years. The watch strap lasts 6 months. So you go out and buy a new watch. So you have 10 watches when you only needed one if you'd had something else that was much more robust. And the sharing knowledge with others without any sort of impediment, trying to make money out of it. So we'll sell you this wonderful technology, but it's going to cost you. So just before I finish up and ask for any questions, just like to give some credits to Emerson, who gave a similar talk at the CCC conference last year. Photographers who I used their pictures from for sharing it, and the Hope volunteers and organisers, all the people who spent the last few months doing all the work. I was here lugging some cables around yesterday, but all the people that probably haven't slept all last night. Thanks to you all. And there's my references. And any questions? Maybe you want to go, I don't know if that microphone's working, just so DVD. Right, I'll repeat the question.
I don't want to ask it that bad, thanks.
Yep.
Back in my computer, I have probably a Christmas tree of various devices plugged in. If I tried to unplug my cell phone charger every time, that's fine. That's one of them. I have probably 40 of them plugged in behind the computer of all the various devices that I have. Is there any strategy for devices that I know they have some of these things that you can plug in that turn off the socket? You turn off the socket, but then a lot of those devices, like a VCR that you've spent 2 years trying to figure out how to reprogram the time so it doesn't flash at you. Then every time you turn off the power, it cancels the programming. So is there any ways to that they're working to just, I'm sure if they just had a little switch that when it wasn't in use inside the power supply, just turn it off. Are they working to do anything about that?
Yeah, I think there's some drivers, some forward movement on some of that stuff. So correct me if I'm wrong, but I think some of the the new Apple stuff has this idea of using 0 watts when it's not actively connected to something. There's also power supplies in computers. Generally, if you go and buy a computer power supply, it's something like, it'll have a stick on the back, 350 watts. So if you have the PC and it's effectively idle, so the CPU isn't drawing much power, the disks are maybe in power save mode, that power supply will still be using maybe 50 watts because the internal components are such that it'll just lose a lot of heat through a resistor if the power is not being actually used. So there is power supplies that have higher efficiencies, although I think they have sort of reached the market, but they're generally quite specific, so they're not being put in PCs by default. The power strip, there's obviously some devices like the mobile phone charger that obviously don't mind. So if you were to have 4 or 5 of them, an easier way of doing that would be to plug it into a power strip with 4 or 5 and just unplug that power strip. But obviously there's lots of these sort of VCRs, some things that probably don't even need a clock in them. So there's these things that have clocks, so microwaves. Okay, you can set your microwave to cook your dinner before you get home. But if you walk around the place, you'll see lots of things flashing 12, 12, 12. So there's definitely some room for improvement there. Any other questions?
You'd mentioned your comparison of boat travel versus airplane travel. What about for land travel? Can you compare the difference between train travel and airplane travel?
Yeah, the question is, I compared the difference between boat and plane, but what's the difference between, was it aeroplane and, say, rail travel? It depends on the distances involved, and also the occupancy of the whatever vehicle. So if a train is full, it has a much better energy consumption per passenger than, say, a car or a plane. But if you have a train with 10 people in it, it's poorer. So generally, if you want to look up the references, it's the one in particular is this Professor David McKay. He has this quite long and very detailed book that's in a draft form that you can get online without hot air. So that goes into a lot of these energy calculations into huge amounts of detail, including why if a plane was to actually reduce its speed, it might actually use more energy in order to keep it airborne. So there's some figures there, but generally, if it takes off the ground, it's high energy consumption. Any other questions? Yep.
I have a big voice, so I don't need the microphone. I just have a comment. I'd be grateful for your response or the response of anybody else. I wanted to address the question of will technological innovations solve the current environmental crisis? And maybe I'll start an argument, so that'd be great. I'm going to say no. First of all, because in spite of all the tremendous technological innovations, underneath there's still a fundamental ignorance about how ecosystems work. We know a lot about the environment, but at the same time, life is so varied and ecology is so complex that we really know very little about the members of ecosystems, how they relate to each other, how different ecosystems interact and affect things like global climate. And so without this knowledge, my question is, how can we expect technology to, I guess, complement the natural environment and help to solve environmental problems in a sustainable way? And there are also a growing number of environmental scientists who are saying that that the pursuit of directly solving environmental problems with technology is a misuse of science. Simply because a lot of research funding through governmental and private bodies tends to go towards flashier areas of science like space exploration, like genetics, like military pursuits, like research that leads to technological innovations. Whereas if we want to solve environmental problems, what we should be doing is devoting more funding to, I guess, more boring areas of science, like systematics and taxonomy, whereby different species are cataloged, the physiology becomes well understood by the energy cycle, and it becomes understood how their species affect the global ecosystem, and so on. So I guess in my opinion, I would say that the best application of technology towards solving environmental problems in a sustainable way are those uses of technology that would help scientists understand life better.
Yeah, in a lot of ways, low-tech technology and less sexy technology, I guess. So, space travel, it's quite politically a good thing to do in things. Although things, as you say, studies into ecology and things isn't as, won't make the news to such an extent. And the example I given there of solar hot water, that's of all the sort of renewable small scale energy, that's the one that's simplest, has least byproducts. So when I was doing my research, one of the sort of hacked versions of this used a small photovoltaic solar cell next to the water panel to run the pump. A lot of the professional, quote unquote, systems actually use electricity to pump the water around the solar panel. So they lose about 20% of the, roughly 20% of the energy in electricity use. So that's the case where keeping it simple is definitely a better plan.
I definitely like to retort. I think I agree that there's no way we can guarantee that we know what certain things we do and their effect, and whether that effect is positive or negative. But I think one thing that you can take a look at the environment is the environment has evolved over a long period of time and in a gradual way. And there are things that human beings do that cause a very strong effect in a short period of time that does make changes to the environment. And it appears that those major changes do cause chain reactions that wouldn't have happened otherwise. Now, there are also environmental things that happen, like hurricanes, earthquakes, that also cause those reactions and also cause negative things to happen. But it appears to me that we're doing so many different things to the environment in certainly causing problems. I mean, the Freon thing with the ozone layer. I mean, that was scientifically proven that that was depleting the ozone layer. So I think it's, and also the things that we do with technology are not to change the environment as it exists, but negate some of the human effects. I think letting the earth kind of slowly do its thing, because we don't know what it's doing. We certainly don't know all of the things that it's doing, and kind of the mentality that we're going in to change what the earth's doing because we think we know what's best. I think I agree. We don't know what's best, but because we don't know what's best, let's err on the side of caution and try to minimize what our effects are and what we do.
I agree completely. My question in response would be, though, if you consider proposed technologies like weather machines and carbon sequestration as ways of reducing human impact on the environment, we still know so little about regional and global ecology. How do we know that implementing this technology isn't going to solve bigger problems?
Right, certainly, and I think humans have proven that a lot of times we try to do something good and we make it worse. So I think, for me, at least personally, it's subtlety on what we do in general, and trying to be careful not to have too much of an effect on the environment from the get-go, and then also subtlety on what our solutions are. But I think it's kind of going for minimal impact on the environment and also not looking for these huge global solutions.
Right. Right. I think we're going to just one more point and then we have to go.
If you come up with a solution that ends an old problem and also creates a new problem, that isn't actually a zero gain. It's better to have different problems one after another and the various self-correcting mechanisms acting on them than one problem hammering the environment again and again for a long time. And there's a certain amount of resiliency in the ecosystem that we know. So even if all we do is change things around, that's a small improvement. And of course, the more we keep messing with things and monitoring to see if we're messing stuff up, the more chance we have of getting the right solution, even if we didn't know ahead of time. Because see it as our technology evolving to meet our environmental effect. Hey, which works, we know that.
Right, that's us done.